Hello MYP4, just another quick video to go through your test on periodicity and trends in the periodic table. So, first question, you had a diagram of the periodic table, 5 elements, W, X, Y, and Z, and the letters are not the chemical symbols, and so you had to work out what each of these letters would represent based on the periodic table. Now, for future reference, and those wanting to study the IB, this block here is often called the S block. This block here is called the P block. And this is the D block, or the transition metal elements. Okay, and then here are the noble gases. So, which element is a transition metal? It had to be in this blue area here, so it, of course, is Y. Which element is in group 2? So group 2 is going to be this one, if that is group 1, so that's W. Which element is a noble gas? Well, that's V in group 8. Which element has an atomic number of 4? So it has to be the fourth one. So 1, 2, 3, 4 would be W again. Sorry, I didn't actually show you counting them. 1, let's do it in a different color. 1, 2, 3, 4. And which element forms only 1 plus ions? That would have to be from group 1, so that would be X. Moving on, question 2. The elements in group 1 are known as the alkali metals. Tick the 3 appropriate sentences about them. So, they're hard, tough, and strong. This isn't true. If you remember the demonstration, I was able to cut them with a knife. So they're not hard, tough, and strong. They are low density. They float on water, if you remember. So they have a low density. Form hydroxides that dissolve in water. Yeah, so if you think sodium hydroxide as an example, and that's formed when we react, say, sodium with water. React quickly with water. This is also true. This the demonstration where we added the alkali metals. They fizzed around on top of the water, and some of them we got to see the color of their flame. Used as catalysts, they're not really used as catalysts. This would be the transition metals, and used to make electric cables. Well, these would ideally be things like copper. Again, transition metal elements. Okay. Use the correct answers from the box to complete the sentences. So Newland's and Mendeleev's periodic table shows the elements in order of their atomic weights. So we can cross that one off. Following the discovery, protons and electrons. Following the discovery of protons and electrons, the modern periodic table shows the elements in order of their proton number. So they go up 1, 2, 3, 4, and so on. Yeah, 1 being hydrogen, 2 being helium, 3 being lithium, and it continues. So they're ordered in their proton number. Moving on, you can't see this diagram properly, but anyway, which one of the 6 elements has the lowest boiling point? That would be hydrogen. Complete the sentence. In the periodic table, rubidium is in group 1, so you can look at your periodic table for that. Which of these 3 elements is the most reactive? You should remember, of the 3, lithium is the least reactive. They're in order, actually, and Potassium is the most. This produced a lilac flame, if you remember that. Which two statements are correct? So iron is a transition metal element, has a higher density than potassium. This is true. Iron is softer than potassium. That isn't true. If you think about things which are made of iron, so steel and buildings and cars, whereas potassium I can cut with a knife. Iron reacts vigorously with water. It does react, it kind of rusts with oxygen present and water, but it's not very vigorous. It takes a long while. If your car, for example, isn't going to react with water in the same way potassium would, otherwise you would have no car the first day it rains. Iron forms ions that have different charges. This is also true. It is a transition metal, and that essentially means it can have multiple charges. You may have seen Fe2 plus and Fe3 plus. They're the common ones. So iron 2 plus and iron 3 plus. Next question. The diagram shows sodium being put into water. The diagram came out on your test, just not in here for some reason. Describe 3 observations that can be seen when sodium is put into water. The first one, it melts. So this one is specifically for sodium. So sodium and potassium would melt. Lithium doesn't melt. So lithium doesn't. And you can tell that it melted because it formed a ball. Formed a little ball of the molten metal. It also floats, and it then fizzes around and moves on top of the surface. So you could have any one of these 4: melts, sodium floats, moves around on the surface, or fizzes if you didn't get one of those first 3. Moving on. Name the gas produced. It would be hydrogen gas. You could have put H2 or hydrogen. Anything in brackets is an alternative answer. Which ion causes the solution to be alkaline? That would be the hydroxide. Question B. Potassium is also in group 1 of the periodic table. Potassium reacts with water in a similar way to lithium, but write down 2 differences. So differences. Potassium reacts or dissolves faster, faster being crucial here. Potassium fizzes faster or more, and potassium moves faster. So everything about potassium is faster. Now, any one of those 3 would have been fine. You only needed 2 though. So I put a third one, this third one in place, in case you didn't get reacts faster or fizzes faster. Question 5. Complete the table. Iodine has been done for you. So chlorine, you need to just remember the names of the colors of their vapors. Chlorine is a green gas. A reddy brown vapor would be bromine. Why do the halogens have similar chemical properties? Is because they have 7 electrons in their outer shell, or you could have also written they have the same number of electrons in their outer shell. What is very important though is you have the word outer shell there. It's no good saying in one of the earlier shells, because what gives chemicals their properties is, so chemical properties are given by the outer shell. The outer shell determines how chemicals are going to react. Next question. The alkali metals in group 1 of the periodic table state what is formed when any alkali metal reacts with water. You are going to form hydrogen gas and heat, and you only needed 2 of these, so you could have also put they form an alkaline solution. So hydrogen gas or heat or alkaline solution, and you needed 2 of them to get the 2 marks. If you put all 3, you still only get 2 marks. Why does iodine have a higher boiling point than chlorine? Iodine is ionic and chlorine is covalent. Well, that isn't true. They're both in the same group. They both form covalent bonds with themselves, so they will both form covalent bonds with themselves. Iodine is less reactive than chlorine. Well, that is it is true, but it's not the reason for the higher boiling point. And the covalent bonds between iodine atoms are stronger. This is also not true necessarily, but you're not going to break covalent bonds. So to boil something, if we have an I molecule and another I molecule, iodine molecule, if I want to separate them, I move that over there and that over there. I'm not going to break, I'll try that again, I'm not going to break this covalent bond. Okay, so it's the forces, or the intermolecular forces between iodine molecules are stronger. Covalent bonds are not broken, but it's the intermolecular forces that are being broken or overcome. Okay, the intermolecular forces. Moving on, predict the boiling point of bromine, anywhere between plus 30 and plus 120. So you just had to look at the difference between there and predict, okay, what's the difference then going to be between there and there. Obviously it couldn't be more than 184, and it can't be less than minus 35. Moving on. The equation for the reaction is Cl2 plus 2Ki aqueous goes to form iodine aqueous plus 2 potassium chloride aqueous. So that's potassium iodide. Potassium iodide and potassium chloride. What is the color of the final solution of this reaction? It is brown. What is the ionic equation for the reaction of chlorine with potassium iodide? 2I minus plus Cl2 goes to form I2 plus 2Cl minus. Why does potassium iodide solution conduct electricity? It conducts, remember this is an ionic compound. Ionic, so it has ions. It's not because it contains a metal. The electrons can move. This isn't true. This only applies, so what I've just highlighted, the electrons can only move, that only applies in metallic bonding. Only. So the ions which can move is the correct answer. Which of the products of electrolyzing potassium iodide solution, what are the products of electrolyzing potassium iodide solution? So that would be hydrogen and iodine. Now I haven't actually covered this. I was putting a extended question to see how much you guys knew above and beyond what I taught you within the lessons, see any additional reading that you've been doing. And you may have figured this one out, but essentially iodine goes to one electrode, so the anode is the positive and the cathode is negative. And the cation in this case, which you have learnt about, so the cation is potassium, and you'd expect it to go to the cathode. However, because it is in solution, there is also water present. So if potassium did form, it would straight away react with the water in the solution and give off hydrogen gas, hence hydrogen being one of the products. And at the anode, the iodine will simply form there because the iodine has the negative charge, so is attracted to the positive anode. just to explain that one more time, so you will have a battery like this, okay, or power supply, and here is my solution. You'll have one which is a positive electrode and one which is a negative electrode. Now, iodine in solution is I-, so it is going to be attracted to the anode, which is the positive one, and potassium, which is obviously positive, it's going to be attracted to the negative one, which is the cathode. However, because there is also water present, if potassium forms, it's going to straight away react with the water and form hydrogen gas instead. Like you already know, as if we put a little piece of potassium on top of water, hydrogen gas is formed. Okay? So hydrogen formed instead of K. Next question, why in terms of electrons are the halogens in group 7? They all have 7 electrons in their outer shell. Outer shell again being important. Moving on, explain in terms of electrons why chlorine is more reactive than bromine. So, chlorine, first of all, for Mark 1, the chlorine atom is smaller than bromine, or you could have said the chlorine has fewer shells. Mark 2 is to say the outer shell of chlorine has a stronger attraction to the nucleus, or you could have said chlorine outer shell has less shielding than bromine. And then finally, Mark 3, so chlorine more easily gains, very important, you have to have the word gains there, an extra electron. So to just put that in diagram form, essentially if you have chlorine, you have 1, 2, 3 shells, whereas bromine has 1, 2, 3, 4 shells. So if there's an electron coming in, the positive nucleus, so the big positive charge is in the center, right, of the nucleus, in the center of each atom, highlighted in yellow. So that attraction, it's a lot easier for chlorine because it's closer, because there's less shells in the way. So this distance is going to be smaller because the atom is smaller. Whereas if there was an electron over here, this distance is going to be bigger. And you've also got to remember, if you've got one electron, let's represent that electron with as E- instead. Electrons have a negative charge, and there are also electrons in this outer shell. So if this electron's trying to move in, it's actually going to be repelled away or pushed away slightly by these 2 electrons, or any electrons in the outer shell. Because electrons, they all have a negative charge, so 2 negatives are going to repel. And this effect, so the pushing away from current electrons, so electrons which are already part of the atom, this is known as shielding. So this is what shielding means. So effectively, the extra electrons in this shell of bromine are going to shield the attractive force between the positive nucleus in the center here, in the center, to the electron which is trying to join the atom. Okay. Question 8. So you had to plot a graph, you got marking points, they had to be within half a box, so it should look something like this, and then your line of best fit, it could be a curve, however it can't be dot to dot. So line of best fit cannot be dot 2 dot. Okay. And then based on whatever your line is, that is where you can make your prediction. So I predicted it at 310. Which of the group elements are solids at 20 degrees? Iodine and astatine. So 20 degrees, you just work from here. 20 degrees is round about there. Okay. And then which are above that? Your iodine and astatine. Draw a diagram to show the arrangement of electrons in an atom of fluorine. It should look something like this. You could have also done it using E- if you wanted to. And that would have also been fine. But you needed 2 in the first shell and 7 in the next one. You couldn't have just done that. That would not be allowed. Explain in terms of electrons why they have similar chemical properties. The same number of electrons in their outer shell. Very important that you have the word outer, and instead of same number, you could have also written 7. Explain in terms of electrons why xenon is so unreactive. So it has 8 electrons, or a full, if you could have written that instead, a full outer shell. So it doesn't need to lose or gain electrons, or share electrons actually. We'll add that in. Or share electrons. And therefore it doesn't need to form bonds, but this is an optional. So you could have said 8 electrons in its outer shell, so it doesn't need to form bonds. Fluorine reacts with xenon, but iodine does not. Explain in terms of atomic structure why fluorine is more reactive than iodine. The same principle with the chlorine essentially. The fluorine atom is smaller, or the outer shell is closer to the nucleus, so it's more strongly attracted, or less shielding. There's that word, shielding. So it gains electrons more easily. So fluorine is a much smaller atom than iodine. Iodine would actually 1, 2, 3, 4, 5. Fluorine is much smaller, so it's a lot easier for an electron to join fluorine than an electron to join iodine. Okay, much smaller distance. Distance is smaller, and there is less shielding. Okay, because iodine is going to have electrons in all of these shells, and so this electron has to be still feel the attractive force of the positive nucleus in the center here, despite all these negative in between. So it's going to feel that force less, and that's the attractive nuclear force. So attractive nuclear force is felt less. Okay. So yeah, Mark 1, Mark 2, Mark 3. Instead, Mark 3 has to be gains electrons more easily, and more was a crucial word. Okay, that summarizes the test. Any other questions, please feel free to email me or speak to me in class. Thank you. Bye.